into full screen. All right, hey folks, welcome to my rant. I'm James, and I've been around for a long time. I'm getting old. So I've worked in infrastructure for several decades and designed a lot of very large infrastructure. So most of the infrastructure, Dropbox, the storage system, and the distributed databases and the data centers and all that kind of stuff. I'm the co-founder and CTO of Convex, a database company, and I spent most of my career either designing big systems or leading large engineering teams. And now I have a company called Convex. This is not going to be a talk about Convex, at least it's not directly about Convex. Obviously, I'm like sneakily shilling Convex in this talk. But just some context for you for this talk. What is Convex as a backend as a service? It's a platform you use to build your applications on. So it's like a database plus a bunch of things. So in Convex, functions are TypeScript RPCs that run on the server. It has full ACID transactions. It does reactivity and caching automatically and gives you end-to-end consistency and type safety. Convex.dev. That's just some context so you know where I'm coming from, right? So Convex is a large platform. We have over 1 million projects running on it. I'm very familiar with what people are building on Convex. Almost all the code written on top of Convex is written by an LLM these days. This is probably not surprising to you, but of all these projects, a very, very large fraction, 90% plus, are written using Claude code or something, right? Interestingly, inside Convex, not that much of our code is written by an LLM. That's not because we're like weird Luddites or anything. Like our dashboard has a ton of LLM generated code. Most of our surfaces are. The actual like database stuff, I don't know. It's not that useful right now, to be honest, right? And we just keep hearing this phrase all the time, software engineering is dying. I find it really frustrating because I think this is not the case at all. I was coming from a startup founder and employer who's, most of their social network are employers, right? There is a massive talent shortage in Silicon Valley, right? Despite all this narrative about the jobs are going away and engineering doesn't matter anymore and Claude does everything, even the labs are desperately hiring engineers, right? Every founder I know is desperately hiring senior engineers, by the way, which is not great news for junior engineers, although there's ways to distinguish yourself by developing architectural skills. But there is an extreme shortage of people with good architectural skills right now. By the way, I am desperate to hire the same people, convex.dev/jobs, right? So, and also, despite all the LLM advances, the senior engineers I speak to every day are not telling me, oh wow, James, I'm just chilling. LLMs have made my job easier, right? They're saying, damn, like my life has gotten harder. I have more code to review, checking correctness all the time. I'm having to spend a lot of time trying to guide my teams towards correctness. So there's a lot more productivity in terms of output, but folks who are like leading and making decisions are struggling and hitting bottlenecks. And I will assert the limited resource in our industry right now is not tokens, right? Sometimes you hear this story. I don't think you believe the limited resources tokens or you wouldn't be here right now, right? You'd just be telling Claude to do something, right? So I think we all deep down believe, right, that you can't just ask Gemini to build Google and it will just pop out, right? There is a lot of architectural design and architecture and guidance that currently is the domain of human beings or platforms. Like I said, the labs are all hiring like crazy. They have Anthropic is hiring right now, by the way, right? They have a lot of access to Claude, right? So the bottleneck is not code, it's correctness, it's simplicity, and it's architecture. And this is in particular for anything that makes money. You can build a game pretty fast, right? But if you wanted to build like a company, something that scales not in terms of number of users or queries per second, but scales in terms of functionality, scales in terms of like demands on the system about correctness, and in particular scales in terms of complexity over time. When you have a huge engineering team and product teams who are demanding all these features from you and you have to have something that doesn't turn into a total mess, right? This is an issue right now. This is still an issue. LLMs are heuristic, we know this. They do a pretty good job still, right? But they are bad at systems and they're bad at architecture. Currently, I think they will be for a while. Because correctness, simplicity, architecture are not particularly heuristic things. So why are LLMs bad at architecture? Maybe one day I'll look silly, right? Maybe this is not going to be the case one day, but right now this is the case, right? Firstly, good architecture involves interactions outside of context windows. It's you've added something to the billing system and it affects the user management system over here. Or we added some concept of teams and it affects what someone did when they're doing accounting, whatever, right? It involves emergent properties over time. Right? So if you're like a senior engineer at a company building interesting systems, you can't tell if your work is good until 2 years later. What happened 2 years later, the requirements have changed, the system got older, the code kind of aged and rotted a little bit in the meantime. It's not easy to measure. I can't give you a benchmark to say whether an architecture is good. And I don't think anyone can. And also, the LLMs are really, really, really good at pattern matching. So far, they're not good at excellence. Most of the time, that doesn't matter. But oftentimes when it comes to how you design a system, how you design a company, how you architect something, oftentimes that is about innovation and excellence. So fortunately this attitude is dying, but 6 months ago I heard this. When we were fundraising a while ago, I had to hear this all the fucking time, right? It doesn't come up so much anymore, but it's like, well, why does anything matter? Why would APIs matter? Why do platforms matter? The LLM will just build it for you, right? And maybe it will, right? But I don't know, do you believe this? Do you want to bet your company on this right now? I bet my company on the opposite right now. Like if you want to build something right now, you have to care about platforms and APIs. Right? You can't just have Claude in a loop build an entire company for you as of right now. Right? So I think we're re-entering something that happened literally half a century ago. Go back to 1968 through 1972. You probably don't remember this unless you're in your 70s right now. So there's this guy, Edgar Dijkstra. You might have heard of this guy. Dijkstra's algorithm, famously smart thinker in computer science. And back then, believe it or not, they had this crisis because computers got better, resources got better, and they just couldn't use it anymore. They were like, holy crap, we can't write software. It's getting too hard to conceptualize all these shared variables. But there was no private data. There was no abstraction. There was no decomposition and object-oriented programming, all that kind of stuff, right? So there was this fear that software engineering as an industry would collapse, even from the top thinkers in the field at the time, right? And then a woman named Barbara Liskov, a bit of a hero of mine, also was my PhD advisor. She came along with this concept of abstraction. How can we take complicated things that are very hard to manage and wrap them up in a simple mental model that's easy to work with, right? And that really unlocked the software crisis and helped us move forwards. I think we're re-entering a software crisis, right? This is not a doomer opinion, right? All I'm saying is that now we're at a point where huge amounts of code can be generated, but we need guardrails to help us turn that into actual sustainable value. Code is accumulating faster than we can turn it into systems, right? But are we fucked? No. Guardrails or abstractions or platforms, I believe, will save us, right? Obviously, convex is one of these, but it doesn't have to be convex, right? So what are good abstractions? A good abstraction makes it hard to do bad things and easy to do good things. That's pretty straightforward, right? But you don't want your LLM going off and doing unsound things, right? You don't need it to go and investigate a whole bunch of like race condition prone code when you can give it the concept of a transaction and everything composes well together. So I think this industry needs more than ever really good platforms that help codify doing good things well and making bad things hard. One example of this, we intentionally built this app generator called Chef on Convex. We haven't worked on it for a long time. We built it in a week. At least at the time, it was best in class at building complex apps. And the reason was just that it had a whole bunch of guardrails. It uses the Convex API. It could only write transactional code. It could only write code that was end-to-end consistent. In fact, it got way better when we just added a prompt that said, don't touch the auth configuration. Just don't mess with this file. Everything, all of a sudden, it sounds so silly, right? But it's not meant to touch that file, so just tell it not to, right? And it just spends time searching other parts of the code base to improve. So what are good abstractions? I'm just going to tell you what I think good abstractions are. These are some of the things I think will allow LLMs to build really good systems, not just like apps, but like companies that grow and have hundreds of people working at them and make billions of dollars over long periods of time, right? Type safety. Why not have type safety, right? Allows the code to not write the wrong kind of data in the wrong places, right? Modularity and information hiding. Sure, an LLM is smart, but it has a certain amount of computational power, of complexity, and have that focused on building blocks. If you hired a principal engineer, they don't come in and say, cool, we're going to get rid of all the building blocks and just write it in assembly code, right? They use modules to build these things. End-to-end consistency. State management, I think, is the hardest problem in computer science. How to have whatever's on your database show up consistently on the client. And I'm going to put a plug-in for transactions. What is a transaction? Just a function that runs all at once atomically. It avoids race conditions, right? These might seem like basic things, but a lot of folks are just neglecting this stuff right now because it's really tempting just to move real fast and build some stuff. But if you want to build an application that turns into a long, durable company, I think these are the things you care about. Now, of course, these are the building blocks. These are the requirements we use to design Convex. If you don't want to think about this stuff yourself, just go use Convex, convex.dev. But I don't care if you want to build stuff from scratch. I just want to put in a really strong pitch right now for the value of abstractions, and that as of 2026, LLMs benefit tremendously from guardrails. Cool, thank you.